Welcome. An airplane flies due west at an airspeed of 425 miles per hour. The wind blows in the direction of 31 degrees south of west at 41 miles per hour. We want to know what the ground speed of the airplane is and what the bearing of the airplane is. Before we begin, however, a sketch is merited. So we know the airplane is flying due west and it is traveling at 425 miles per hour. Additionally, we know that the wind blows 31 degrees south. There you go. So 31 degrees south of west at 41 miles per hour. Here I have a very basic sketch. And if we were to add these vectors here, oopsies, I didn't mean to do that to the screen. Here's this vector. We put them tip to tail. There we are. And you'll see why I'm adding these in a second. I just want to move this 31 degrees out of the way to make it a bit easier to see what's going on here. So this vector V represents the airplane with respect to the ground. Now let's label our other vectors, and I'm going to label and color code them real quick. So this one here, the wind, I'll make the wind blue because I think of the sky when I think of wind, and the airplane. Let's see. I mean, it's something industrial, man-made, so how about we give it this purplish color? There we are. So now I'm going to call V sub P the airplane. That's the vector representing the motion of the airplane, and W is the wind. So how do we figure out the ground speed? So let's label this part A. Well, the ground speed of the plane, so the speed of the plane with respect to the ground, and I should double check that no one misses this. This is with respect to the ground, is the magnitude of the V vector. So V can be found with vector addition by summing V sub P and W. V sub P is fairly easy to find. Let me show you why it is fairly easy to find. So I'm going to copy this vector here. And let's go ahead and do this on the side. And also make some space for more of this work. I've made a little bit more space here. And so I'm going to go ahead and draw an X and Y axis. X, Y, and then here's my vector, V. There we are, there's V. V runs right along the, V sub P. V sub P runs right along the x-axis here. And what would this point be? Well, we know that the magnitude of V sub P is 425. So this point here is negative 425, comma 0. Now, what does that tell me? That tells me that V sub P is equal to negative 425, comma 0. Now let's figure this out again for the wind. So I'm just going to copy and paste here, and I'm also going to scroll up a bit. There we are. So here's another X and Y axis. You don't have to draw so many, but I find it very helpful to have them all in different places so I can focus on one thing at a time. And right now I'm focusing on the wind. And I know this here, the wind speed itself, is 41. So that's the magnitude of this vector. I also know that this angle is 31 degrees here. And what I want to find out is this point. So this point right there. Notice that makes a right angle with the axis. So this is a right triangle. And this point is going to have an x component and a y component. And I don't know what those are, but I can use trigonometry to find this. Recall that cosine of an angle equals the adjacent side, which is x, over the hypotenuse. And sine of an angle is y over the hypotenuse. And I'll just write h for that. So in our case, h is equal to 41. That's the length of this vector representing the wind here. So then to find x, we know that x is going to equal our hypotenuse times cosine of theta. So x is equal to 41 cosine of 31 degrees. And then I have a calculator here that you should be seeing shortly. I'm going to make sure I'm in degree mode. So mode, there's degree. And this kind of emulates a TI calculator, but it's not a TI calculator. I think I paid like $5 for it on the App Store a decade ago. Who knows what it is now? Hopefully not a subscription. So then I'm just going to type in 41 times cosine of 31, and there it is. So I know x is equal to approximately negative 30. Oh, look at this. Hold on. I got a positive angle. So I'm going to stop right here because I realize I should do one last thing first. This is technically not the angle we want. We want this angle. What I found was the x value here for 31 degrees. So that x value is 35.143. That's the x value here. But that's not what I wanted. I want this angle here. Well, this angle is 180 degrees plus 31 degrees. That's 211 degrees. There we go. So now let's go ahead and fix that here. I'm going to pop in this 211, and there's my calculator again. And so I'll just go ahead and delete this and go 211. There it is. So x is approximately negative 35.143859. Now we need to do the same thing to find the y value. And I'm going to rearrange again just to make a little more space for that. So the y value is equal to our hypotenuse times sine theta. So y is equal to 41 sine of 211 degrees. Now back to the calculator, 41 times sine of 211 degrees, that's negative 21. Well, approximately. I'm writing a few places after the decimal, mostly because I don't like to round so early. It's better to round at the end and be more exact. So what this tells me is that my w vector is equal to about negative 35.14, comma, negative 21.12. And now while I round it here, when I do my computations, I'm not going to round as much, and you'll see that when I pull the calculator back up. So now that I have these values, I can say V is equal to negative 425 minus 35.14, comma, 0 minus 21.12. And so all I've done, is add these component-wise, add the x's here, and add the y's here. Now on my calculator, what is that? Negative 35 and change minus 425, that is negative 460.143. I'll just put 0.14. But again, I won't use the rounded values in my calculations. And this is negative 21.12. So now to find the speed relative to the ground, all I need to do is find the magnitude of V. And that's equal to the square root of negative 460.14 squared plus negative 21.12 squared. And so let's go back to our calculator. I'm going to do second root, open parentheses, and then tap that 460 so I get the exact value, square that. If you're using a TI calculator, you can definitely scroll up, see with these keys. But since I'm on my phone, I don't need to use those keys. And then to that, I'm going to add, open parentheses, the y component squared. And so the speed of the airplane relative to the ground is about 460.628 miles per hour. If you were typing this to my open math, you should probably type in a few decimal places from the calculator. If you were writing about this verbally, I would say, and let me scroll up for this, the speed of the airplane relative to the ground is about 461 miles. Let me just do mph. per hour, so I don't run out of space. And now, why did I round it so much? None of us talk like this. None of us say, "Oh, I was going, that airplane was going 468.2 or 460.28 miles or whatever." I'm getting the decimal wrongs, but no one would say 460.628 miles per hour. We would say, "Oh, it's about 461 miles per hour." That's how we talk. So I always suggest that when you're communicating results, you communicate it in a way that's more natural, like spoken language natural, not in the exact mathy way. Okay, now let's consider part B. So for part B, what is the bearing of the airplane? So let's do another picture, and the bearing is just the angle that this resultant vector makes. So let's go ahead and draw our picture. Here's our x and y axes. And there we are. Ah, it's a little off. Not quite a right angle, so actually, here I go, making mistake after mistake. Let me fix that. There we go. Okay, now this works a little better. So, and let me move this. You can see my process for how I make pictures now. X, Y. So there's my axes, and now I'm going to paste the vector. I love that about technology, that everything is kind of exact in that way. Let me scooch this over for space. There we go. So here's our resultant vector V, and what we're looking for is this angle here. What is this angle? Well, if you remember about V, and I should extend this so we can see this better, we already know what its x value and y value are. What I mean is extending this to be a right triangle here along the x-axis. Oh, that doesn't look like a right triangle at all. There, that's better. So that's a right triangle. We know that this point here is negative 460.14, comma, negative 21.12. That's that point right there. So now we can use trig. Since we have an x value and a y value, remember that the tangent of an angle, so tangent of theta, is equal to the y value, the opposite over the adjacent. So tangent of theta, which we don't know yet, is equal to negative 460.14 divided by negative 21.12. So theta is approximately, now I'm going to go back to my calculator, and I do want to be more exact. So I'm going to go here, second tangent inverse, and instead of typing this in, I'm going to scroll up until I find my, there it is, my negative 460. And now I'm going to divide that by the negative 21. And I just realized why. That's not what I expected. Look at this. I did x over y. That's cotangent. So basically, if I do 1 divided by this, wow, never mind. Let me just fix this directly. So this is my mistake I made. Those of you watching this video at home are probably like, no, don't do it. Like when you watch a horror movie and someone goes outside in the dark by themselves, you're like, no, go back inside. Anyways, so now let's go ahead and do this again. Now that my brain fart has been fixed, let's go here to negative 460. So tangent inverse of negative 460 and change divided by, there's my y value, close the parentheses. Oh my God, I did it again. Wow, I really am not going well today. I think I need more Starbucks. So there we go. Tangent inverse of negative 21 and change divided by only one division symbol, negative 460. There it is. Theta is about 2.62, not 162, let's say 8 degrees. And what direction it is? It is south of west. And let's go ahead and write out our answer. The bearing of this airplane is about, and this one I'm probably gonna write it as a decimal because it's like not close enough to 3 where I want to say about 3, and it's definitely too far from 2 to write that it's 2. So I'm going to say it's about 2.6 degrees south of west. Those of you in my class who are doing this on My Open Math, you actually need 4 decimal places. So you know what? Let me fix that here. Um, so if we write this to 4 decimal places, it's 6275 degrees. Okay, I hope you found this helpful. Please keep calm and math on.